Hello and welcome to the course of manufacturing method. In this course, so far we have studied about casting, metal forming, and in the last lecture we have just introduced with you one important topic, that is machining. Now in this lecture we will study about uh, a bit detail of this machining. So in this lecture, the lecture title is, this is the third module and this is the 11th lecture of this top of the course, and the topic name is type of cutting tool, tool geometry and tool signature. This we will study in this lecture. So in this lecture, the lecture objectives are to understand about different type of cutting tool. We will understand about different type of cutting tool, to introspect about orthogonal and oblique cutting, and to get insight of tool geometry, to know about different tool signature and how to use them. So let's start with cutting tool. So according to cutting action, the cutting tool can be classified in two cases. First one is left hand cutting tool, second one is right hand cutting tool. In case of a cutting point, so what is point? Point is a cutting tool look like this, a single point cutting tool. That single point cutting tool looks something like this. A single point cutting tool look something like this. Now Now we will see that cutting the the point means whole cutting edge, whole cutting face is known as point. Means for a cutting tool look like this, this whole section is known as point. Or you may say that the section which is responsible for cutting. So at the time of cutting, how many point is connected with the workpiece, that will define the cutting point. And according to that, cutting tool can be of single point cutting tool, multi point cutting tool and double point cutting tool. That we will see in the later section what is what. And so first, left hand and right hand cutting tool. So what is right hand cutting tool and what is left hand cutting tool? When the feed is given to this direction, means when you put your right hand like this, and if the feed is in the direction of, if the feed is in the direction of your thumb, then the tool is known as, then the cutting tool is known as left hand tool, right hand tool. So this is right hand tool. When this is right hand tool, when the feed is given in this side, at that time this tool is known as right hand tool. See, you may imagine like this also. If you take your if you put your right hand, if you put your right hand on the top surface of the machine or machine tool, then this this your right hand may look like a cutting tool, may look this your right hand may look like a cutting tool, and the feed is given on the thumb. And again, when you use your left hand, and when this left hand, when you put your left hand, and this hand is look like the cutting tool, and at that time this is the feed. So this is right hand cutting tool, and this case, in this case, this is left hand cutting tool. So these are the difference between right hand cutting tool and left hand cutting tool, and this is how you understand what is left hand cutting tool and which one is right hand cutting tool, by checking the principal cutting edge. See, this is the principal cutting edge and this is the auxiliary or secondary cutting edge. This edge is auxiliary or secondary cutting edge. What is secondary or principal cutting edge, that we will come later on. So now this is the difference between these are the first two classification, that is left hand cutting tool and right hand cutting tool. So here we can see that. Next, the cutting according to the point, according to the cutting point, there is single point cutting tool. In single point cutting tool have only one cutting point. The example of a single point cutting tools are turning tool, shaping tool, slotting tool, etc. are the single point cutting tool. Similarly, double point cutting tool means those cutting tool which have two cutting point. For example, drill bit. So you can see the drill bit. If you see the cross section of a drill bit, means if you see from here, this is the drill bit. If you see from here, you may see the drill bit may look like this. Drill bit may look like this. Now at the time of cutting, at the same time, two cutting edge, this cutting edge and this cutting edge, two cutting edge is is touched with the workpiece. So that's why it is called double point cutting tool. Similarly, milling cutter. This is a milling cutter. This has multiple points. This has multiple cutting points. See, these points are one cutting point. This is one cutting point. This is another cutting point. So like this, there is n number of cutting points, and these cutting points. There is more than two cutting points. So that's why it is called multiple cutting, multiple multi-point cutting tool. And this is the single point cutting tool, and this is the cutting point. Not only the nose radius, but also the whole cutting part. This part is known as cutting point. Now we will see about orthogonal cutting and oblique cutting. In orthogonal cutting, what is done in orthogonal cutting? Cutting tool is perpendicular to the direction of the tool motion. Cutting tool kept perpendicular to the direction of the tool motion, or cutting tool is kept perpendicular to the direction of the tool motion. So or tool feed. So when it is perpendicular, then the chip will flow perpendicularly above the rake surface, or above the perpendicular to the cutting edge. Chip will flow perpendicular to the cutting edge, and this type of orthogonal cutting is known as two-dimensional cutting. While in oblique cutting, what has happened? There is an inclination between direction of cutting tool motion, and there is an inclination between uh, direction of the tool motion. So this is the direction of the tool motion, and this is this is the orientation of the cutting tool. So cutting tool is not placed placed perpendicularly to the cutting tool motion. Uh, so it is at an angle. So the flow of chip is not perpendicular to the cutting edge, and the tool has greater cutting life as compared to this type of tool. Oblique tool has greater cutting life as compared to orthogonal tool, and this oblique cutting tool, this operation is known as three-dimensional operation. Okay, now we'll see the difference between oblique and orthogonal cutting. This difference many times come into the your semester exam, but and this is so important. So in case of orthogonal cutting, what is there? Orthogonal cutting angle of the tool make right angle with the direction of the motion. So cutting angle makes right angle with the direction of the motion. In case of oblique cutting, the cutting angle of the tool does not make right angle with the direction of the motion. It does not make right angle with the direction of the motion. The chip flow is perpendicular to the cutting edge. Flow is not perpendicular to the cutting edge. Tool life, orthogonal cutting has lesser tool life, but in case of oblique cutting, the tool life will be higher as compared to orthogonal cutting tool. The shear force per unit area is high because it increases heat per unit area. So which increases heat per unit area, and shear force in case of oblique cutting is low. That means heat is also low. This cutting chip flow over the tool, or in orthogonal cutting chip flow over the tool. In oblique cutting, chip flow along in sideways. So in case of oblique cutting, chip flow will be in the sideways, and in orthogonal cutting surface finish is poor, but in case of oblique cutting good surface finish may occur. The cutting edge uh, is longer than the edge of cut. Cutting edge may or may not be longer than the edge of cut, and two mutually perpendicular cutting force act on the workpiece in case of orthogonal cutting, but in case of oblique cutting, three mutually perpendicular forces are involved. So that's why it is called oblique cutting is called 3D cutting operation, and orthogonal cutting is called 2D cutting operation. So now we will see about tool geometry. So what is tool geometry? Tool geometry is nothing but it's a distinguishing of the tool and how the tool look and what is the perfect shape of the tool, and so that it can give us maximum productivity. So in the tool we can see a single point cutting tool. This is only single point tool geometry of a single point cutting tool is in our syllabus. So we will study that only. So in the single point cutting tool, we can see the in this figure we can see the distinguished part of the single point cutting tool. So first what is there? First there is shank. Shank is nothing but the body of the tool. This is the body of the tool. This body goes into the tool holder, and so that's why it is the holding part of a cutting tool. That is shank. Opposite to the shank, the part is known as just opposite to the shank, the part is known as base. This is the base. Okay, just adjacent to the shank. Next is face. What is face? Face is nothing but the upper portion of the cutting tool. This is face, and and adjacent to the face, side of the face, this portion are known as flank. There is two type of flank. One is major flank, another is minor flank. Major flank is the intersection between face and major flank is the major flank if the feed direction is in this side, means the tool is, if the tool is our if this is side cutting edge angle, then then after the side cutting edge angle there is major flank, and if it is this is end cutting edge angle, just beside end cutting edge angle, the flank will be minor flank, and this radius is known as nose, and just opposite to nose the point is known as heel. So these are the distinguished part, and this face is known as rake face, and this is what I have said, this is flank. So these are the general nomenclature of the tool geometry. Now we will see about the tool geometry angles. There are several angle in the tool geometry. So first there is rake angle. The rake angles are mainly used for chip flow. So easy flow of chip can be given by the rake angle, and rake angle there are two type of rake angle. One is side rake angle, one is back rake angle. So two angles are there. Next there is relief angle. The work of relief angle is to give clearance between machine surface and the workpiece. So this clearance is given by the relief angle. There is two relief angle. First one is side relief angle, second one is end relief angle. So side relief angle and end relief angle both remove both resist the possibility, both remove the possibility of getting rubbed with the workpiece. And there are two type of cutting edge angle. First one is end cutting edge angle, second one is side cutting edge angle. And in case of end cutting edge angle or side cutting edge angle, the things are there. The first that mainly depends on the principal and secondary cutting edge. So what is principal cutting edge? Principal cutting edge is nothing but, in case of, see, in case of this left hand cutting, this edge is principal cutting edge. Principal cutting edge means the edge which is in the direction of the feed. So that is principal cutting edge. So in the principal cutting edge, what will be there? Side cutting edge angle will be there, and in case of end cutting edge angle, end cutting edge angle will be there. So this is the tool geometry of the angles. Now we will see about the definition of those angles. So first, and the view, mm, by which we can see those angles. So from the top view, like here, if we insert a plate here, then what we can see? We can see side cutting edge angle and end cutting edge angle. The definition of side cutting edge: the angle formed between the cutting end cutting edge, and line perpendicular to the shank. This is the line perpendicular to the shank. This is the shank, and this is the line perpendicular to the shank, and this is the end cutting edge. So angle between them is known as end cutting edge angle. Similarly, angle between the line parallel to the shank, this is the line parallel to the shank, and this is side cutting edge angle. That would give us side cutting edge angle. This is side cutting edge, that will give us side cutting edge angle. And in between them, this is nose radius, and this nose radius can be given as nose angle also. So this angle is known as nose angle. Now in case of rake angle, if we see from the side, means we insert a our observation plate here, then we can see the shape like this. So if we put this shape like this, then here we can see three angle: this angle which is with the perpendicular, which is with the this angle, this is the this is the parallel to the shank line, and from the parallel to the shank line, this angle is known as back rake angle, and this angle which is with the perpendicular to the base, that would give us end relief angle. And the angle between them, this angle is known as wedge angle or lip angle. So depending upon the wedge angle and lip angle, this wedge angle and lip angle depends upon the rake angle only, back rake angle, and the value of the rake angle can be positive, negative, and zero, that we will show later on. So next we will see side rake angle. This, for seeing this side rake angle and side relief angle, for seeing this we have to see the workpiece from the front side, like this, and by cutting this portion out we can see a face like this, and if we straighten it up, then this angle, that means this angle is side rake angle, and this is your side relief angle. So these are the different angle, and these angles, the main application of this angle is to give strength to the workpiece first, give strength to the cutting tool first, secondly to remove the material more efficiently. These are the work of the tool geometry, or work of this angle, and according to this angle and this six angle and one nose radius, a tool can be specified. That is why mainly the tool is specified in the terms of angles. So those angles are mainly from the angles from this tool geometry. Now those angles can be designated by specific signatures. Those are known as tool signature. And the tool signature, there are four type of tool signature. First one is Asa system, Second one is ORS system. ASA means American Standard Association System. That ASA is very useful. This system is very useful for regrinding and inspection. And this system is also called tool in hand system. In case of ORS system means orthogonal rake system, and it is mainly used in Germany, Czechoslovakia, and other European countries. This is mainly used for analysis of metal cutting. So the ASA system is not suitable for the application for the analysis of metal cutting, but ASA system is can be used for regrinding and inspection operation, while ORS system can be used in case of metal cutting analysis. Next, there are two modern techniques or modern system. First one is NRS system, that is called normal rake system. This is the new Indian standard organization system in India. Right now, this system, NRS system, has been followed, and here in case of NRS system, you can see that each and every angle are true angle. That means there is no imaginary angles are there in the tool designation or tool signature. And the MRS, in case of MRS, that is known as maximum rake system, and the here concept of maximum rake plane has been introduced. So maximum rake plane means the rake angle will be maximum, so that the easily chip formation can be done very easily. So uh, the in our syllabus, or the system of importance are two, that are ASA and ORS system. So we will study about ASA and ORS system only. So see, in case of ASA system, there are three plane. ASA system is tool in hand system, and it is also called machine reference system, because first I am saying that there are three plane. First plane is this reference plane pi r, second is machine longitudinal plane pi x, and next is machine longitudinal feed, and next is machine transverse feed plane, that is pi y. Now we will see the different six angle and one nose radius. So by knowing this, we can generate the tool dimension or tool signature. So for ARS, see here, this angle, this is the cutting tool, this is the cutting tool, and this in this side feed is given. So as in this side feed is given, this cutting edge is known as side cutting edge, and this cutting edge is known as end cutting edge. So angle between the horizontal and side cutting edge is known as side cutting edge angle. So this is side cutting edge angle, and this is end cutting edge angle, and this angle is end cutting edge angle. Now if we see from this x means, if we see the workpiece from here, if we see the system from here, what we can see, we can see the work tool like this. This we can see in the pi x plane by and the pi x plane means we just put a bar, we just put a slice here, we just cut this lower part out, and we are seeing the upper part only. So what we can see, we can see like this, and this angle, then when we can see like this alpha x and gamma y are the, so gamma x is the back rake angle, and alpha x is the, sorry, gamma x is the end or side rake angle, and alpha x is the side clearance angle. Now if we see from the front, means if we see from here, if we see from here by cutting this cutting through this y plane, then we can see this is alpha y. That means this angle is end end clearance angle or back clearance angle, and this angle is known as back rake angle. So So this is in pi y plane. So pi r, pi x, pi y. All three planes are in the reference with the machine. So that's why ASA system is known as machine reference system. And the tool signature will look like your first there come the gamma y, gamma x, alpha y, alpha x, sigma e, and sigma s, and r, that r is nose radius, that will be in inches. So if we say the terms, that is first back rectangle, next side rectangle, next back clearance angle, side clearance angle, end cutting edge angle, side cutting edge angle, and then up at last there is nose radius. That nose radius will be also be in inch. Now in case of ORS system, what will be there? In case of ORS system, then that is known as, this ORS system is known as tool reference system. The machining is not required. So there is three plane: cutting plane, an orthogonal plane, and a reference plane. So orthogonal plane, cutting plane is inside, the cutting plane is in the direction of the cutting principal cutting edge, that is sigma in this phi range, this is phi, and auxiliary cutting edge will be the edge means, and the principal cutting edge is the cutting edge in the direction of feed. The, this is the principal cutting edge. So this is the principal cutting edge. So on that principal cutting edge lies one plane. That plane is known as cutting plane, C pi c, and perpendicular to that a plane lies. That plane is known as orthogonal cutting edge or orthogonal plane, and with perpendicular to these two, that means orthogonal and pi c, there exists a plane. That plane is known as reference plane. Okay, so this picture is drawn in reference plane, and this is orthogonal. In the reference plane, what we can see? We can see principal cutting edge and auxiliary principal cutting edge and nose radius. These three things we can see in the reference plane. Now in the orthogonal plane means we are seeing, we are cutting the workpiece from here and seeing, and by that what we can see? We can see that only orthogonal rectangle can be seen. This orthogonal rectangle can be seen, and this gamma 0, that means gamma 0 orthogonal rectangle can be seen, and orthogonal clearance angle can be seen. And in case of here, this end relief angle, in case of pi c cutting edge, that end relief angle, phi end relief angle, and the yes, in case of here, end relief angle can be found. Now for finding out our auxiliary orthogonal clearance angle, that for that a auxiliary plane is imagined, and that auxiliary plane, in that auxiliary plane we can see this alpha 0 dash value, and that's why we can say that this alpha, that 0 value, is not a true angle, it is a imaginary angle. So the tool signature for ORS system will be like this. First there will be inclination angle, next there will be orthogonal rake angle, next there will be our auxiliary next there will be orthogonal clearance angle. Next there will be orthogonal auxiliary orthogonal clearance angle. Next auxiliary cutting edge angle. Next uh, side cutting edge angle, and R, that is in mm. So these are the tool signature. So thank you for listening, and in this lecture so far we have covered the basics of tool geometry and types of tool and tool signature. So I think this will be enough for your syllabus, and if you need to know anything else, you may ask why on the live class. Thank you.